Hey guys, welcome to another video. Now in this video we're covering two specific topics which we have looked at in the past. This is the idea of scientific notation, so an application of indices, as well as rounding to different amounts of significant figures. So I'll try to go a bit quicker through some of these explanations, because we've covered this already at length before. So this is slightly kind of like a revision lesson. So please, if any of this is new or looks weird, have a look at those previous videos just to get you up to speed. Now, let's look at scientific notation first. Now, scientific notation comes out of the numbers we use in science. So when scientists measure things or they work with certain experiments, they are often dealing with really big or really small numbers. Now, I'm not going to give you a really big number, but I'm going to give you a number and see how we can convert it to something that is a little bit easier to digest. So I have this number. Yeah, let's go 60,000. So this isn't too big, but let's think about how we can break down this number. So with scientists, when they deal with this, usually they've got even more massive numbers. They got all these zeros happening here. So they want a nice compact way to communicate the scale, how big this number is, as well as to just have it really compact and easy to read. Because when they're coming up with writing these papers on these things, they don't want to keep writing these really big or small numbers with all these zeros or decimal points attached. So we want an easier way to express this. So this thing is equivalent to writing a 6 and multiplying this by 10. 6 by 10 gives me 60. If I multiply another 10, this gives me 600. If I multiply that by another 10, that gives me 6,000. And by another 10, that gives me 60,000. So what we're trying to do here is we're breaking down this big number into a multiplication of sorts. So the product of 6 as well as the multiplication of a lot of the same number. And with what we know from indices in index form, we can write things from these expanded forms into a nice compact thing. Because 10 times 10 times 10 times 10, this is like writing 10 to the power of 4. So in essence, I can write 60,000 as 6 times 10 to the power of 4. And when we get even bigger numbers, this is going to be really useful, because anytime we have all these zeros attached, we can just think of this as times 10 to some power, however many tens there were multiplying by each other. And significant figures, the second part of this, has to do with rounding. So I covered the rules of this a lot in previous videos, so it's going to take too much time to go through this. So let's just jump straight into writing numbers first in scientific notation and then rounding these to significant figures. Because we need significant figures as we want to approximate things sometimes. It's not always useful for us when we think of something like population, which fluctuates a lot. We want roughly an estimation, roughly how many people are there in the world. We don't need always an exact amount, so we want to round. And significant figures give us a way to do this. So look at this first question here. So I have 2,183,000 here. Now, first I want to convert this to scientific notation. So if you remember from the previous videos where we talked about this, we can think of, because this is a whole number, there being a decimal point right at the end here. And all of our numbers in scientific notation, this guy here is typically between 1 and 10. That's just convention. So this is between 1 and 10. So if we bring this decimal point back, 1, 2, 3, 4, 5, 6, and get it here to make this 2.183000, this now gives us this number of this part of the scientific notation between 1 and 10. And by counting, we can see, well, how many times was this multiplied by 10? So we can say, well, we had 1, 2, 3, 4, 5, 6. So that means that my number becomes 2.183. Now I can write these zeros too if I wanted to, but I'm going to end up rounding them anyway, times 10. And how many jumps did we do? This is all in the previous video, so please consult that if this is not super clear. But we did 6 of these. So in other words, to get back to 2,183,000, I can take 2.183000 and multiply it by 10 to the power of 6. So this is a condensed way to write my bigger number. Now, I have this in this form, but I want to convert this to 3 significant figures. So I want to count, well, I have 1, 2, 3 significant figures, these non-zero numbers in this case. So that means that once I get to the point where I want to round, the degree that I want to round, I'm considering the next number here, this 3. And when we round, if the number following this one here is 5 or more, we're going to round up. But if it is 5, or if it is less than 5, sorry, we're going to round down. So since this 3 is less than 5, we round down. So my number here to 3 significant figures is 2.18 times 10 to the power of 6. So let's try another example. So let's try example B here. This is, we have 0.00194882. And I want to write this in scientific notation. Now, if you remember, I've said this before, for scientific notation, this number has to be between 1 and 10. So we want to get this decimal point to a number somewhere between here. We want to move its location so that we're making a number between 1 and 10. So if we think of moving this decimal point, we want to go here, here, and then here finally. And that's going to give me 1.9482. Now this is a number now between 1 and 10. And we want to see, well, how many times did we go in the right-hand direction? So I have 1, 2, and 3. So think about this now, because the number I've written here is a number bigger than the one above, because the number above is a decimal. So in essence, we're not making this number bigger, we are making it smaller. So we can think of this as, to get from 1.9482 to 0.00194882, I'm actually dividing by 10 3 times, aren't I? I'm dividing by 10, and then I'm dividing by 10, and then I'm dividing by 10. So, dividing by 10, I can also write that as multiplying by its reciprocal. We've talked about this before in fractions. So dividing by 10 can be rewritten as 1 over 10 times 1 over 10 times 1 over 10. Now I'm doing this the long way just to really give you a bit of an understanding of how this works. So if I do this multiplication here, I'm going to get 1.9482 times, now all of my ones on the numerator multiply, and down the bottom, 10 times 10 times 10 gives me 10 to the power of 3. Now if we remember with our negative indices, I can rewrite this thing here, 1 over 10 to the power of 3, as 1.9482 times 10. 10 will be my base, and I can find the reciprocal of this and change the sign here from positive 3 to negative 3. So this becomes my answer. So this is how we can think of scientific notation in the other direction. The top one, the first example we did, is a little bit easier because we're more used to it, but this one on the bottom, we can think of this as multiplying by a negative indice, which gives the effect of dividing by 10 3 times. Alright, one more example, and I'm going to give an application type of question here. So we can look at another part of this topic, which is using our calculator with scientific notation questions, as well as just general problem solving and application. So this question tells us that the diameter of Earth is approximately 12756,000 meters. So 12,756,000 meters. So the sun's diameter is 109 times that of Earth. That should be a capital E. Okay, and we want to find the sun's diameter here. So it's 109 times the size of Earth. So I'm going to pop into my calculator 109 times 12,756,000, and I'm going to get an answer of, okay, I'm going to write out all these digits here. Okay, this is my answer, and this was in meters. So I want to express this answer in scientific notation correct to 3 significant figures. So my 3 significant figures are going to be these 3 here. So I'm going to basically stop at my 3rd significant figure 9 here. And because I am, the number after that is a 0, then it just stays as 139 when we end up writing it in scientific notation. So for scientific notation, I want to see, well, how can I get this number to a number between 1 and 10? Well, I'll need my decimal point to wind up here, because 1.39 is in between 1 and 10. It can't go here because then I get 13.9. So it has to be between the first 2 digits. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9. So my answer is going to be 1.39, and I'm going to stop here because I want this to 3 significant figures, and I'm going to go 39 because the number to the right of 9 was 0. It's less than 5, so we round down, and this is times 10 to the power of 9 meters. Because if we count, just to double check, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we can make this number back, the one up here, by taking 1.39 times 10 to the power of 9. But you can see this thing on the bottom is way more compact. It's way nicer and more compact to look at. That is why we use scientific notation sometimes as opposed to working with these really big numbers. Because if you're a scientist writing a paper, it's going to get pretty boring writing this number out a bunch of times. And as I've said before, mathematicians are lazy. We're always looking for shortcuts to writing things, especially expressing them. This is going to be a lot easier to write all over again, over and over again, than this thing up here. But this is how we can bring together what we know about scientific notation and significant figures to actually start to now answer some problems in this field. But thank you so much for watching, guys, and I'll see you in the next video.